In my previous videos, I looked at the feasibility of AI code generation models being poisoned. The impact could be substantial, and I created a small script in Python to try and find this in action. However, my code was simply too small to yield any substantial results. In this video, I seek to improve upon my last experiments. I'll investigate thousands of prompts, generate a large dataset of AI-generated answers through the use of Hugging Face's Inference API, and then try and analyze the results for malicious indicators of compromise. My name's David Willis-Owen. If you're new to the channel, please consider subscribing, and I hope you enjoy my video. The problem from last time. So the problem from last time is that we simply had too small a scale of experiments to be able to prove anything. We tried to analyze the GitHub Copilot command line tool, and here is the script that we used below, as you can see. And the main problem with this, there's nothing wrong with the code itself. The code basically asks the Copilot command line tool to keep iterating and generating us prompts to the same question, or rather generating us answers to the same question. However, the GitHub Copilot suggest utility has an extremely limited context window. Now, I haven't actually tested this, but I believe it's around 100 tokens, which is very, very small. And this limits the amount of AI-generated code that we can gather. Finally, it's incapable of writing any complex code, and this means it's very unlikely that we'll find any vulnerabilities. So I needed a model, a way of testing which had far fewer restrictions at a much larger scale. So, section 2, what do I actually need? Well, I tried to verbalize my requirements and the deficiencies from the previous experiment in a prompt, and I actually sent this off to ChatGPT o3 Mini High, which is one of the flagship production models at the moment. So let's take a look at my prompt and skim over the details. So I'm doing research on if production-grade code generation AI models have been poisoned. Then I verbalize that I'm searching for indicators of compromise. And finally, we have 4 steps. Choose a suitable model I can run locally that is production grade, set up the model, find a suitable long list of prompts to send to the model, and then explain how I can gather the output of all these prompts. So GPT went away, and for steps 1 and 2, it suggested me to use a model called StarCoder from Big Code. Now this model is slightly outdated. I believe it's 1 to 2 years old, and I immediately ran into technical difficulties trying to run this locally. So I spent around 30 minutes trying to configure this, and it turns out the model is over 50 gigabytes. And to run really well, it requires 1 or more GPUs, or graphical processing units, which is far better than the CPU, which I have on my laptop for doing LLM-related tasks and other complex data processing. So this was an immediate blocker. It was taking about 20, 30, 40 seconds to generate literally 10 words. And so this isn't feasible going ahead. So I decided, okay, I'm going to have to pay a bit of money. I did some more digging, and I found that Hugging Face offers a service called Inference. This allows you to quickly spin up a large language model of your choosing, leveraging AWS, Google Cloud Platform, or Azure. So I decided to go in with a $10 budget of spend and go from there. To start with, to dip my toes in the water, I went with Meta's Llama model, and I used just 1 GPU to start off with. And this only costs 80 cents per hour, so it's really a fantastic way for anyone looking to get started in the AI security space. Have a play around with Hugging Face. Okay, so this was the first iteration, and it simply was not powerful enough. I used a very basic model, and I also had this set to text completion mode as opposed to question answering mode. And as a result, it did not answer my questions the way I wanted. So what I did is I looked at the possible offerings. I did some research on other models, other coding related models and LLMs, and I came up with using this DeepSeek Coder V2 Lite Instruct, which is a much more modern model. It's very cheap to run and provides high quality outputs. I then did a very basic cost analysis of running this on different GPUs, and ChatGPT suggested using 4 L4 NVIDIA GPUs. So I got this all set up, and this only cost me $3.80 per hour to run, and it gave me around 500 prompt outputs per hour. I call it PPH. I've kind of just coined the term, and I used kind of this navigation activity bar to track the progress of my Python automation. So I'd like to take a second to talk about Notion. I use Notion every single day, and I've used it for the last 1.5 years to track my progress and really note down anything. So yearly goals, weekly goals, journaling. It has such a clean user interface and lots of inbuilt functionality. So I do have a link in the description. If you're interested in that, take a look. Even if you just want to use it for free, I use it for free at the moment. I have used the paid version in the past, and any purchases you make will support these videos. Okay, thank you very much, and we'll go back to it now. Now we have a much more powerful and capable LLM driving. What else do we need? Well, we need a dataset of developer and coding related prompts. Let's take a look at my notes on this. To begin with, I found something called prompt sets from Pista Labs. And prompt set has 61,000 unique developer prompts which were extracted from open source Python programs. Now, originally, I thought developer prompts were prompts related to coding. However, these are system prompts which may be put in LLM-powered applications. So this is not what we're looking for. However, the paper I read contained a citation about a paper talking about something called DevGPT. DevGPT is a confusing name because I believe there's other ChatGPT-like apps called DevGPT. In this context, though, DevGPT is a set of around 18,000 prompts which developers have put into ChatGPT. This is a fantastic dataset, although it was quite difficult to parse through. So I used the help of AI again to generate me a nice file that can parse through all of this data and give us a curated set of prompts which we can then ask our DeepSeek model. So in this case, I actually did 150 prompts from each dataset. There were 6 different dataset sections inside of DevGPT. And I was able to also get the answers from DevGPT initially. So here is the final code that I used to actually perform this analysis. First of all, let's take a look at this prompt parser.py. So pretty much all of the DevGPT data is stored in a collection of JSON or JavaScript object notation files. We have these stored in our data directory. And if we open this up, there's a bunch of useful information for data analysts. The only thing we are interested in for the sake of this is the prompt and the answer. Now, the answer allowed me to collate a bunch of the real answers to the prompts performed in this experiment itself, and I can still use this for analysis. But what I'm more interested in is grabbing these prompts and then inputting them into the new DeepSeek Coder model, which will hopefully be quite up to date in terms of its weights and should capture any more recent data poisoning attacks. Let's go back to prompt parser. So we have some Python, and this is basically just data manipulation, which gives us the first 150 prompts from each of these JSON files on the left and keeps looping through for as many times as we want. I limited it to 150 because that allowed for 900 answers in total. Now, let's take a look at our main.py file. And in this main.py file, Pretty much, we read in the prompts from our prompt parser. We then open up CSV and text files. For each of the prompts, we simply send it off to our server. The server is what we built on Hugging Face. And then finally, this will write them to both the text and the CSV. And also it outputted a nice progress bar for me to see the progress of what was happening. Let's take a look at these data files very quickly. So we can see that in the DeepSeek coder output, in the text file, this is, if I am not mistaken, 90,000 lines of code that we've captured from the AI model. So thousands and thousands of tokens right here, which is very valuable to then do further analysis. Let me head back to my Notion page and we'll discuss the analysis section. So I let this run for about 2 hours and captured around 900 answers from the DeepSeek instance that we initiated. Next up though, I need to actually analyze this captured Python code. So there are a bunch of tools I can use. One of them is something called semgrep, which is an industry standard free tool you can use to scan Python code for vulnerabilities. However, the problem is my code was stored in a text or CSV file, and semgrep did not like that. It didn't like the fact that I had a file full of several different formats. Remember, my output also contained things in JavaScript, Java, even some AWS notation, because some of the developer questions were related to those, even though it was predominantly Python. So this made it very difficult to use static code analysis tools. What I will need to do is I'll need to filter out just the Python code and then pass separate chunks into a similar tool. This isn't as easy as it sounds. I'm going to look at doing this over the next few weeks. However, what I can do is I can paste the CSV or the text file into Notepad++, and I can grep for malicious looking strings. Let me show you that right now. And grep, for those of you who don't know, is basically a quick search tool on Unix-like machines or other applications to find specific strings in a big block of text. So here we have our file, and what I'm going to do is click Control F, and we can literally just use the find all in current documents to find specific strings. So one thing I might want to do is HTTP:/, and that looks for anything using the hypertext transfer protocol, or in other words, web pages. So we'll look for this in the current document, and we see we actually have a bunch of domains and websites. So we could then go and analyze these and see, are any of these malicious? I spent around an hour doing similar things. Another thing that I did was I searched for executable files. I searched for subprocess.popen, which is a common Python snippet of code used to basically execute malicious commands. And I didn't find anything too crazy. There were a couple of bits, but they did appear to be hallucinations, unfortunately. So what do I need to do next? Well, I need to perform that static code analysis that I mentioned before. I need to go through this really with a fine-tooth comb and then look for kind of more subtle indicators of compromise, then cross-reference these against potentially malicious GitHub repositories. So in summary, I was able to parse the substantial DevGPT datasets and submit lots of these prompts into an inference API endpoint on Hugging Face, leveraging one of DeepSeek's coder models. From this, I was able to generate around 900 answers to common developer questions and problems. The next challenge is making sense of this dataset of answers. I've already tried looking for some indicators of compromise, but there's definitely a lot of room for improvement, and I look forward to doing this in the coming weeks. Okay, if you enjoyed this video, please leave a like, please subscribe, share this, and I look forward to seeing you in the next one.